Good morning, everyone. Today we are going to discuss about one of the important topics from JRF point of syllabus, JRF syllabus point, that is crop production technology. Crop production technology in rice. Rice, as we all know, it is the major staple food crop of our country, and majority of questions might be asked from this rice crop. This rice, we know scientific name is Oryza sativa, and chromosome number is 2 n equal to 24, and area is 43.89 million hectares, and production is 117.47 million tons, and productivity is 2578 kg per hectare, that is 2.5 tons. And the rice is the staple food for more than 60% of world population, and for the most people of Southeastern Asia, it is the staple food crop, and about 90% of rice grown in the world is produced and consumed in Asia, that is our continent itself. And it is a crop which is grown in wet tropical climate and also grown in humid regions of subtropicals. Rice crop prefers hot and humid climate, and it contains very less protein compared to other cereals. Its protein content is only 67%, and it contains 2 to 2.5% of fat. And till now, 22 species of Oryza are recognized, of which only two are being cultivated. First one is Oryza sativa, that is being cultivated in Asia, and next one is Oryza glaberrima, that is being cultivated in Africa. In this Oryza sativa, three subspecies are recognized, that are Indica, Japonica, and Javanica. First one is Indica subspecies. It is indigenous to India, and it is adapted to subtropical and tropical regions. These indica varieties are very tall and photosensitive, prone to lodging, poor fertilizer responsive, moderate filling, and late maturing. Here, here these varieties are very tall. That means they are prone to lodging. At the stage of at maturity stage, panicles will weigh more, so that they bend towards one side, which is called as lodging. Because of their tallness, lodging happens, and they are poor fertilizer responsive. That means how much or we apply the fertilizer, yield will be limited only, and moderate filling and late maturing, and photosensitive. Photosensitive means they are highly sensitive to the light, sunlight, and morphological differences between the varieties are very wide. Generally, these indica varieties are awnless. It is important point. These indica varieties are awnless. Next one is Japonica. It is confined to subtropical temperate regions like Japan, China, and Korea. These Japonica varieties are dwarf, erect, non-lodging, photoinsensitive, early maturing, high yielding, and fertilizer responsive. You have to remember this. These Japonica are very dwarf, which is advantageous, and non-lodging. Because of their dwarfness, these varieties are non-lodging, and photoinsensitive, which is good, and high yielding, and fertilizer responsive. Fertilizer responsive means if you apply the more amount of fertilizer, more amount of yield will come in Japonica. एक किसानों के लिए फायदा है फेकले रेस्पॉन्सिव वेराइटीज. Japonica varieties are high yielding compared to the indica varieties, and the morphological difference between the varieties is very narrow, and these Japonica varieties are on less, but indica varieties are also on less, and crosses were made between these indica and Japonica varieties. First cross developed was ADT 27 during 1964. The next one is Javanica. It is a wild form of rice and it is cultivated in some parts of Indonesia. Generally, these Javanica varieties are tallest, erect, poor filling, and armed. First, Indica and Japonica varieties are armless, but these Javanica it is armed. Here we can see the types of season for rice cultivation. And generally, three seasons are present. First one is As, Aman, and Boro. This As season it is also called as autumn season. It is grown during this autumn season. It is sown in the month of March to April and harvested during August to September. And in West Bengal and Bihar, it is called as As rice. Next one is Aman. It is also called as Kharif rice and winter rice. Aman is derived from Arabic language meaning winter rice, and it is sown during June and July and harvested in the month of November. Next one is Boro. It is also called as summer rice. It is sown during the month of November and December and harvested during May month. In Orissa, the summer rice is called as Daluva rice. Here we can see the difference between As, Aman and Boro. As it is a Bengali word meaning early, and Aman it is a Arabic word, and both As and Aman rice are direct seeded, and this Boro rice is transplanted rice, and the As rice is sown during March and April and harvested during July and August. This Aman rice it is sown during May and June and harvested during October to December, and this Boro rice it is sown during December to January and harvested during April to May. These sowing months and harvesting months are very important from exam point of view. They might confuse you with by giving harvesting month, like some As rice is harvested during July and August, and this both As and Boro rice are photo period insensitive, but Aman rice is photosensitive, and As and Aman both are sown during pre-monsoon. That means they only depend upon rainfall. But this Boro rice it is sown during December and harvested during April. That's why it is irrigated, because during this duration only little amount of rainfall is expected. That's why it's completely depend upon irrigation source. But this As and Aman rice both are grown during pre-monsoon. That's why they depend upon this monsoon season. That means rainfall. And next is rice morphology. Soon after sowing rice, it gives out seminal roots from the radicle, which are temporary. आप लोग ये याद रखना कि seminal roots मतलब हमेशा वो temporary रहता है. Regardless of the crop, the seminal roots are temporary, and real functional roots are secondary adventitious roots. Adventitious roots यानी कि वो लोअर नोड्स ऑफ स्टेम से डेवलप होता है, इसलिए एडवेंटिशियस रूट्स कहे जाते हैं. और ये रियल रूट्स है, मतलब परमानेंट रूट्स है. And root system remains in the top 20 centimeters for transplanted rice, but for direct seeded rice it is more deeper. It depends upon water availability and soil physical properties. You have to remember that root system remains means it is short in transplanted rice, but it is more deeper in direct seeded rice. And rice stem it is also called as cum, and it is hollow and it is made up of nodes and internodes. Stems are shorter in direct seeded upland varieties compared to transplanted varieties. In direct seeded varieties, stem length is about 90 centimeters, but in transplanted varieties, it is about 130 centimeters. First, Root length is short in transplant rice, but stem length is more in transplanted rice. And rice leaf consists of sheath and blade. यहाँ आप लोग देख सकते हैं ये लीफ शीथ है और ये लीफ ब्लेड है और ये जंक्शन में इसको कहा जाता है कॉलर है, लीफ कॉलर। यहाँ एक छोटा सा स्ट्रक्चर है, उससे कहा जाता है लिग्यूल है। एंड ओनली वन लिग्यूल इज प्रेजेंट इन द राइस लीफ along with the two auricles, one ligule and two auricles. At the junction of sheath and blade, a papyrus structure called ligule and two auricles are present. And inflorescence of rice plant is born on terminal shoot and it is known as panicle. And at maturity, panicle becomes very heavy. Because of that, it may cause lodging if varieties are tall. And this panicle is terminate type and droopy in nature at maturity. And transplant rice consists of 6 to 10 panicles per plant, whereas direct seed varieties have 3 to 4 panicles per plant. ट्रांसप्लांटेड राइस में पैनिकल्स का नंबर ज़्यादा है, इसलिए वो हमेशा हाई यील्डिंग वैरायटी है ट्रांसप्लांटेड वैरायटीज। बट डायरेक्ट सीड में पैनिकल्स नंबर कम है, जितना मतलब यील्ड हमेशा पैनिकल्स का नंबर पर डिपेंड होता है। एंड राइस फ्रूट इज ए कैरियोप्सिस इन विच सिंगल सीड इज फ्यूज्ड विद द वॉल ऑफ ओवरी एंड सीड as usual it consists of endosperm and embryo. Every plant seed consists of endosperm and embryo. Here rice fruit is caryopsis and inflorescence is panicle. Here are two types of are there. One is lowland varieties, upland varieties. Upland varieties means just growing rice just like wheat crop, but lowland means that growing of rice in submerged soils. Submerged soils are nothing but growing in flooded soils. सबमर्ज्ड सॉइल्स में हमेशा पानी रहता है और उसमें ऑक्सीजन नहीं रहता है। वो there are some characteristics of submerged soils which are favorable for rice crop, particularly for rice crop. Submerged soils they increase the pH of acidic soils and decrease the pH of sodic soils. Means generally acidic soils का pH बहुत कम रहता है और sodic soils पे ज़्यादा रहता है। और सबमर्ज्ड सॉइल्स में अगर हम एसिडिक सॉइल्स को सबमर्ज करेगा तो उसका pH बढ़ेगा और सोडिक सॉइल्स में घटेगा। यानी ये सबमर्ज्ड सॉइल्स न्यूट्रल रहता है, मतलब इसका न्यूट्रलाइजिंग इफेक्ट है, वो प्लांट के लिए अच्छा है। और रिडक्शन कॉन्सेंट्रेशन ऑफ ऑक्सीजन, एज वी नो इफ वाटर इंक्रीजेस इट रिड्यूस द कॉन्सेंट्रेशन ऑफ ऑक्सीजन, दैट्स व्हाई इट इज कॉल्ड एज एनारोबिक सॉइल। And anaerobic soil it will be in reduced zone. Because of absence of oxygen, these nitrates will be reduced to nitrites. Thereafter they will be reduced to nitrogen. Nitrates to nitrites and nitrites to nitrogen. That is called reduction. And this is also this process is called as denitrification. And if sulfate is present, it will be reduced to sulfide. It might result in sulfite toxicity, which is harmful for the rice crop. And this sulfide, it will react with the hydrogen and it forms hydrogen sulfide. Hydrogen sulfide causes AQC disease in rice crop. Here normally manganese will be present in the form of Mn+4 and Fe present in the form of Fe+3, that is ferric form. This in case of submerged soils both will be reduced to Mn+2 and Fe+2, but up to certain limit this Mn+2 and Fe+2 are favorable for the rice crop because rice takes iron and manganese in the form of Fe+2 and Mn+2. But if they exceed certain limit, it might result in manganese toxicity and iron toxicity in rice crop, which is harmful. And next one is types of nurseries. 3 types of nurseries are present. First one is dry nursery, wet nursery and depot nursery. For dry nursery, seed rate is 2.5 to 3 kg per meter square, and it is prepared in the areas where sufficient supply of moisture is assured only through rainfall and soil is free to retain moisture. यानी कि ड्राई नर्सरी जिस एरियाज में इरिगेशन सोर्स नहीं है उसमें ड्राई नर्सरी किसानों बनाते हैं और उसमें सिर्फ इरिगेशन के लिए हम रेनफॉल के ऊपर डिपेंड करते हैं। लेकिन ड्राई नर्सरी का एक दिक्कत ये है कि उसमें यील्ड बहुत कम आता है कंपेयर टू वेट नर्सरी। Here field is plowed repeatedly to a fine till and raised beds of 4 to 5 centimeters height and 1 to 1.5 meters width and of convenient length. And next one is wet nursery. Wet nurseries are generally high yielding compared to dry nurseries. Generally, they are raised in areas with assured supply of irrigation. If irrigation source is there, if irrigation sufficient supply is there, then we will go for wet nursery. And if irrigation source is not there, only rainfall is there, that means we have to go for dry nursery. And this wet nursery, it is the best method for obtaining well-grown seedlings within a short period of time. Land is first plowed under dry or moist conditions, then puddled by ploughing. After these beds are prepared and sprouted seeds are broadcasted or line sown on these beds, then nursery will be prepared. Seed rate is same as dry nursery, that is 2.5 to 3 kg per meter square. And we know for growing 1 hectare of rice crop, optimum size of nursery is 1000 meter square, that is 1/10 of land. And Dapog method, this is commonly prevalent in Philippines. These beds are prepared and covered with banana leaves or polythene sheets to prevent the roots of seedlings from coming into contact with the soil. First हम बेड्स प्रिपेयर करना है, उसके बाद बेड्स को बनाना या पॉलिथीन शीट से कवर करना है, क्योंकि ये जर्मिनेशन होने के बाद सॉइल से टच नहीं होना है, क्योंकि इस ट्रांसप्लांटिंग समय में थोड़ा सा आसान होगा, इसलिए बेड्स को बनाना या पॉलिथीन शीट से कवर करते डपोक मेथड में। और यहाँ भी सीड रेट है कि 3 kg per meter square, सेम एज ड्राई एंड वेट नर्सरी। For first 3 and 4 days, seedlings are kept moist by sprinkling water, and seedlings will become ready for transplanting within 12 to 14 days, regardless of duration of the variety. आप लोग ये याद रखिए कि डपोक मेथड में सीडलिंग्स 12 to 14 डेज में रेडी हो जाएगा, एंड ड्राई एंड वेट नर्सरीज में नॉर्मली 25 to 30 days है। And normal spacing for rice crop is 20 into 10 centimeters or 20 into 15 centimeters. In some areas, they may follow 15 into 15 centimeters also. And it is transplanted at the rate of 2 to 3 seedlings per hill. And depth of transplanting is generally 2 to 4 centimeters. And hulling percentage of rice is 75%. And milling percentage is 66%. That is 2/3 of rice. Hulling means first paddy grain is there. It is surrounded by husk. If we remove the husk, that process is called as hulling, and that hulling percentage is 75%. After hulling, rice obtained is called as brown rice, and brown rice again we will go for milling process, where we will remove the pericarp and aileron layer. That process is called as milling. After that milling process, 2/3 of rice will be remained, that is 66%. And the seed rate is generally for broadcasting purpose, seed rate is 100 kg per hectare. For hybrid rice, it is 15 kg per hectare, and for drilling, it is 60 kg per hectare. And system of rice intensification, it is also very important concept from exam point of view. It was developed by French priest Francis S.J. Henry de Lalani in Madagascar. SRA mainly consists of 6 principles. Farmers grows the SRA based on these 6 principles. First one is planting young seedlings at the age of 8 to 10 days. आप लोग याद रखिए कि नॉर्मल नर्सरीज में 25 to 30 days हम ट्रांसप्लांटिंग करते हैं, बट डपोक मेथड में वो 14 days है, बट SRA मेथड में वो 18 to 10 days है। और एक और प्रिंसिपल है कि नेक्स्ट प्रिंसिपल सिंगल सीडलिंग पर हिल। यहाँ आप लोग देख सकते हैं नॉर्मल ट्रांसप्लांटिंग राइस में 2 to 3 सीडलिंग्स पर हिल हम ट्रांसप्लांट करते हैं, बट SRM में ओनली सिंगल सीडलिंग पर हिल, and it is square planting, that is 25 into 25 centimeters. That means plant population is very less compared to transplanted rice. And application of organic manures, these inorganic fertilizers will be completely avoided or reduced. And weeding through 1 to 2 manual or mechanical weedings. Manual weeding means labor will do manual weeding with the help of spade, or mechanical weedings with the help of cone weeder. And alternate wetting and drying. Alternating wetting and drying means in transplanted rice में हमेशा हम पानी का लेवल मेंटेन करते हैं 5 सेंटीमीटर, लेकिन दिस SRA में for first 7 days or 10 days we will keep the water, again it will be drained out, again after 7 days again we will irrigate the field. That is called as alternative wetting and drying. And water management in rice. Rice is the largest consumer of water. In cereals, pulses and millets, it is the largest consumer of water. About 5,000 liters of water is required to produce 1 kg rice. Here these 3 points are very important. Water required for raising seedlings for 1 hectare land is 40 to 60 millimeters for 1 hectare. That means for nursery preparation 40 to 60 millimeters of water is required, but the water required for puddling and transplanting is 200 to 300 millimeters. And from transplanting to harvesting, water required is 800 to 1200 millimeters per hectare. So total water required for growing 1 hectare rice is around 1200 to 1500 millimeters, which is very high compared to other cereals, pulses and millets. And these 3 points are very important from exam point of view. Water required for raising seedlings in nursery, water required for puddling and transplanting, and water required from transplanting to harvesting. And in paddy field, water is mainly lost through runoff, percolation, seepage, and evapotranspiration. Generally, this ET requirement, that is evapotranspiration requirement of rice, is about 4 to 5 mm per day during wet season, and 7 to 17 mm per day during the dry season. मीन्स वेट सीजन में एवापोरेशन कम है क्योंकि वेट सीजन में पानी रहता है और एटमॉस्फेयर में मॉइस्चर भी रहता है, ह्यूमिडिटी ज़्यादा रहता है, और ड्राई सीजन में ह्यूमिडिटी कम रहता है और सॉइल मॉइस्चर भी बहुत कम रहता है, इसलिए एवापोट्रांसपिरेशन रिक्वायरमेंट ज़्यादा रहता है ड्राई सीजन में. और एक्टिव टेलरिंग, पैनिकल इनिशिएशन एंड फ्लावरिंग, these 3 are the most critical stage for irrigation. That means for suppose active tailoring stage is there, अगर हम इस स्टेज में पानी नहीं दिया या पानी का लेवल कम है और सॉइल मॉइस्चर लेवल भी कम है तो यील्ड बहुत घटेगा. उसके बाद आप जितना पानी भी डालो लेकिन यील्ड तो नहीं बढ़ेगा, इसलिए वो मोस्ट क्रिटिकल स्टेज है. इन तीनों स्टेज में आप पानी का लेवल मेंटेन करना है. नेक्स्ट वन इज वीड मैनेजमेंट. Weeds are generally more in upland rice compared to lowland rice. Discharge sanguinalis, Cynodon dactyla, Paspalum scrobiculata. These are the grass weeds which are harming the rice crop, which are infesting the rice field, and sedges like Cyprus rotundus and Fimbristilis miliaceae. Cyprus rotundus and Fimbristilis miliaceae. And broadleaf weeds like Commelina bengalensis, Amaranthus spinosus, Ezeratum conizoides, Eclipta alba, Eclipta costa, and Hydrilla verticillata. This Hydrilla verticillata, it is an aquatic weed. In exam, they might ask like by giving these options, they may ask which of the following is a grassy weed or which of the following is a broadleaf weed. So आप लोग ये भी पढ़ना है कि मतलब ये classification grasses, sedges and broadleaf weeds. Here only few examples are given, but you have to read thoroughly about this grass, sedge and broadleaf weeds classification. And pre-emergence herbicides. This butachlor recommendation is 1 liter per acre. This is the one of the mostly used pre-emergent herbicide in rice crop. And another flaws Prettilachlor 600 ml per acre, Londex powder, that is benserpran methyl plus Prettilachlor 4 kg per acre. Next one is Sati pyrosulfuron ethyl 80 ml per acre. This pyrosulfuron, it is now newly emerging herbicide. This pyrosulfuron ethyl, it is a chemical name and Sati is a trade name. In exam, they might ask that about chemical name and trade names of herbicide also. So I have to read that part also. Next one is post-emergent herbicides. This post-emergent herbicide, bispirbex sodium, that is 20 to 25 grams per hectare. It is applied at 20 to 25 days after transplanting. It is mostly used post-emergent herbicide in the rice crop. Next one is Almix, that is metserpran methyl 10% plus chloromuran ethyl 10%, 8 grams per hectare. It is applied after 20 to 30 days after transplanting. Next one is Algrip, that is metserpran methyl 20% wettable granules. A recommendation is 8 grams per hectare. It is applied at 20 to 30 days after transplanting. Next one is 2,4-D sodium salt, that recommendation is 1 kg per acre. It is applied at 25 to 30 days after transplanting. And in exams these days, they are asking about this recommendation also. They are giving, for suppose they are giving 2,4-D sodium salt. What is the recommendation of 2,4-D sodium salt in the rice crop? So you have to choose the option 1 kg per acre. Next one is Beechening. Beechening means cross ploughing the young crop 4 to 6 weeks after sowing with a light country plough in 5 to 10 centimeters standing water, once or twice depending upon density of weeds and crop stand. This means हम क्रॉप लगाने के 1 महीना या 1.5 महीने के बाद लाइट कंट्री प्लो से क्रॉस प्लविंग करना है फील्ड में इन 5 to 10 सेंटीमीटर स्टैंडिंग वाटर. हम 1 बार या 2 बार कर सकते हैं. इट डिपेंड्स अपॉन डेंसिटी ऑफ वीड्स एंड क्रॉप स्टैंड. इससे मेन फायदा ये है कि वीड डेंसिटी कम हो जाता है बीशनिंग से. एक बीशनिंग के बाद हम थिनिंग और गैप फिलिंग कर सकते हैं. इससे क्या जाता है किलुआ ऑपरेशन. फर्स्ट हम बीशनिंग करते हैं, उसके बाद थिनिंग या गैप फिलिंग करते हैं, उससे किलुआ कह जाते हैं. ये बीशनिंग ज़्यादातर मध्य प्रदेश, छत्तीसगढ़, बिहार, उड़ीसा इन स्टेट्स में फॉलो करते हैं. Next one is nutrient management. Nitrogen, it is very important for rice crop. There should be always optimal nitrogen level for getting high yield in the rice crop. Nitrogen recommendation for lowland and irrigated rice in most of the states is 120 to 150 kg nitrogen per hectare. Rice generally prefers ammonical nitrogen, but remaining most of the crops prefer nitrate form of nitrogen. In nitrogen, two forms are there: ammonical nitrogen and nitrate nitrogen. This lowland rice prefers ammonical nitrogen. And this rates of NPK application for rain-fed rice is about 20% is less. Rain-fed rice means if irrigation source is not there, Kisan farmers only depend upon rainfall. That is called as rain-fed rice. Generally, while growing rain-fed rice, soil moisture will be less. That's why we are going for 20% is less of application of fertilizers. As we know, this fertilizer application depends upon soil moisture level. अगर soil में ज़्यादा moisture है, हम fertilizer apply कर सकते हैं, क्योंकि plant moisture के द्वारा nutrients uptake करती है. इसलिए अगर soil moisture level है तो हम more fertilizers, high application of fertilizers apply कर सकते हैं. तो प्लांट न्यूट्रिएंट अवेलेबिलिटी ज़्यादा रहता है और यील्ड भी ज़्यादा आता है. लेकिन अगर सॉइल मॉइस्चर कम है तो ज़्यादा फर्टिलाइजर अप्लाई करने से भी कुछ फ़ायदा नहीं है, क्योंकि सॉइल मॉइस्चर कम है तो प्लांट न्यूट्रिएंट अपटेक न्यूट्रिएंट्स लेना बहुत मुश्किल है. और बैलेंस्ड एनपीके फर्टिलाइजर इज ए मस्ट फॉर हाई यील्ड. हियर यू रिमेंबर बैलेंस्ड एनपीके फर्टिलाइजेशन, बिकॉज जनरली किसान क्या करते हैं, मतलब 50 to 100 kg या 150 kg यूरिया डालते हैं, और लेकिन फास्फोरस या पोटेशियम को छोड़ देते हैं, कम्प्लीटली इग्नोर करते हैं. तो ये बैलेंस नहीं रहता है, इसलिए वो क्रॉप के लिए हार्मफुल है। इसलिए हमेशा बैलेंस रखना जरूरी है। जनरल एनपीके रिकमेंडेशन फॉर राइस वेरीज फ्रॉम 120 to 150 kg of nitrogen, 30 to 60 kg of P2O5, 20 to 40 kg of K2O per hectare. And we farmers should not ignore the micronutrients also, like iron, zinc, boron. These three also very important for rice crop. In lowland soils, waterlogged puddle soil develops two zones. First one is oxidized zone, that top 1 to 10 millimeters thin surface layer, that is 1 centimeters layer. It consists oxygen. That's why it is called as oxidized zone. Below the oxidized zone, it will be in reduced state. That's why it is called as reduced zone. Here we have already discussed that two types of zones are there: oxidized zone and reduced zone. And these ammonical fertilizers, they should be always applied in reduced zone, and nitrate fertilizers, they should be applied always in oxidized zone. Here we can see that if you want to apply the nitrogen fertilizer should be applied only in the oxidized zone, or it should be completely avoided, because it is prone to losses like leaching and denitrification. So this ammonical fertilizer, it should be applied in reduced zone. One scientific reason is there, because if you apply the ammonical fertilizer in this oxidized zone, this ammonia, it will react with the oxygen and it forms nitrate. After that, this nitrate will goes downwards. That means it will goes to reduced zone. There it will be reduced to nitrogen, and it will be lost. That process is called as denitrification. So this ammonical fertilizer, if you apply them in the oxidized zone, this ammonia, it will react with the oxygen and it forms nitrate. After that, after formation of nitrate will go downwards to the reduced zone. In reduced zone, it will be reduced to nitrate. Nitrate will be reduced to nitrogen, and it lost in the form of nitrogen. That's why we should not apply an ammonical fertilizer in oxidized zone. And one more loss is, if you apply ammonia in oxidized zone, it might lose through volatilization also. Just it will evaporate into the atmosphere. So we should always apply ammonical fertilizer in the reduced zone. So here we can see ammonium polyphosphate. It is a complex fertilizer. It is superior to DAP and SSP in acidic soil. In case of acidic soil, it is better to apply ammonium polyphosphate compared to single superphosphate and diammonium phosphate. Here we can see the word complex fertilizer. कॉम्प्लेक्स फर्टिलाइजर यानी कि इसमें एन और पी रहते हैं, दो मेजर मैक्रो न्यूट्रिएंट्स रहते हैं, इसलिए कॉम्प्लेक्स फर्टिलाइजर कहे जाते हैं। और कंप्लीट फर्टिलाइजर मतलब तीनों मैक्रो न्यूट्रिएंट्स एन पी के रहना है, then it will be called as complete fertilizer. That is the difference between complex and complete fertilizer. And one word is there, compound fertilizer. If two nutrients are present, means regardless of macro or micro, it is called as compound fertilizer. So आप लोग याद रखना है, compound fertilizer में दो nutrients रहते हैं, जो भी हो, या macro या micro हो, उससे compound fertilizer कहे जाते हैं। लेकिन complex में दो macro nutrients रहना है minimum complex fertilizer में, but complete fertilizer में तीन NPK, तीन macro nutrients रहना है। Here we already discussed deep placement of ammonium fertilizer in the reduced zone has proved to be efficient method compared to other methods. So ammonium fertilizers, they have always to be applied in reduced zone only. And nitrogen is efficiency of rice is 30 to 40%. This is also a very important point. Next one is bronzing of rice. This iron toxicity in rice is known as bronzing of rice. We have discussed this rice prefers Fe+2 form, but if it exceeds a certain limit, it causes toxicity and it causes bronzing of rice. This iron toxicity is the major problem to rice production in waterlogged acidic sulfate soils of altisol and oxisol soil waters. These are acid soils. In these soils, iron toxicity will occur because in acidic soils, this iron concentration will be more. And this beginning of iron toxicity is characterized by appearance of purple coloration at the leaf tips, finally as a scorched appearance. We already know that acidic sulfate soils, this iron and aluminum concentration will be more. So it might cause iron and aluminum toxicity, which is harmful for the rice crop. This Falguna variety of rice, it is tolerant to iron toxicity. Silicon, it is also very important for the rice crop. Silicon deficient plants are soft and droopy, and silicon supply mostly required during paniclination stage, because at this stage this root activity is very less, so it might cause lodging and rate of transpiration is very high. So silicon is essential for the rice crop. And plus one advantage is that if silicon is present in the crop, it provides a thick cuticle which functions as a barrier against attack by insect pests. So if silicon is present, it protects the crop from these pests also, because it forms a layer around this crop. And paddy, it is generally harvested at about 20 to 26 percentage of moisture content, and it has to be dried about 16 to 22 percentage before threshing. Threshing means separating of grains from panicle, and the percentage of white rice grain obtained after milling is 66 percentage. We have already discussed milling percentage of rice is 66 percentage, that is 2/3 of rice, and hulling percentage is 75 percentage. But both this hulling and milling depends upon this variety drying process and storage also. And next one operation is parboiling. This is a hydrothermal treatment given to paddy for improving its milling quality and nutritive value. This parboiling, it is highly beneficial for rice crop. First, in this process, first rice is soaked in water. After that, it is steamed at high temperatures, and after steaming, it is dried to room temperature. This here we can see that parboiling improves head recovery, vitamin and micronutrients in the rice crop, because we know that during milling this pericarp, bran and elluran layer, they all will be removed during milling, so that we can obtain the white rice. But one disadvantage is that this ellulan layer consists of vitamins and nutrients. So during milling, it is getting removed. So majority of vitamins and minerals will be lost through milling. But if you do parboiling, in parboiling, these vitamins and micronutrients, they move from ellulan layer to grain. So even if you remove ellulan layer during milling, these vitamins and micronutrients, they will remain in grain. So it will be advantageous. So this parboiling is highly beneficial for rice crop because it improves nutritive value. And these are the byproducts of rice milling. You know, husk means that is the brown layer surrounding the rice grain. It will be removed during the hulling process. This husk, it can be used as a domestic and commercial fuel. It consists of 20% of ash, of which 90% is silica. Here don't confuse, like husk doesn't consist of 90% silica. It consists of 20% of ash. In this ash, 90% is silica. So husk mainly consists of silicon, and it is used for making sodium silicate, silica gel and charcoal. Next one is bran. It is getting removed during milling process. It is ellulan layer separated from brown rice. Here we can see it consists of 12 to 15% protein, 4 to 25% oil, and rich in vitamin B complex. Here we already, these days we are hearing that brown rice, it is very healthy for us, because brown rice, this bran is present. During brown rice, only hulling is done, that means husk is removed, And brown rice consists of protein, oil, and these vitamins. But after that brown rice also we are going for polishing in the sense milling. That's why this bran and allurar layer they are getting removed. So this protein, oil, vitamins, all they are getting lost because of this milling process. At last we are getting white rice. Although it is looking nice, but it's not good for health because it only consists of starch, that is carbohydrate. That's why doctors are advising us to eat brown rice because it consists of vitamins, proteins, and minerals. Next one is broken rice. Broken rice, it can be made into flour and used for making many rice dishes. Broken rice का main फायदा है कि वो पोल्ट्री का फीड में पोल्ट्री के दाने के लिए यूज करते हैं broken rice को. These are the byproducts of rice milling: husk, bran, and broken rice. Thank you. First, I want to tell you that this from crop production of point of view, very little amount of bits are coming, very less objectives are coming in the exam. But mainly they are asking current affairs from this crop production of view. So you have to remember area, production, productivity, and newly released varieties by ICR or some research institutes from ICRISAT or international institutes. Every year they are releasing the newly varieties, biofortified varieties, or this drought tolerant varieties, yeah, flood tolerant varieties. So you have to remember all these varieties. In general, these all basics we have covered in this class. Plus this, besides this theory part, you have to be thorough with the current affairs, area, production, productivity. So you remember all those varieties, newly released varieties. They might ask one or two bits from newly released varieties.
Excuse me, sir.
And recommended bit is
Hello.
hello.
Sir, can you please provide us with current data?
Okay, I will share you in a group the current affairs.
And sir, please, actually, I was late today, so please, can you give us today's lecture in the group?
Okay, okay, it will be available. I think it's available in YouTube. That link will be provided to you.
Okay, sir. Okay.
Um, Mainly means this is theory part. Very less bits are coming from this theory part. Mainly they are asking about current affairs. That is also important varieties. So you have to be thorough with those varieties. And recommended book is that Rajendra Prasad crop production is there. Two volumes are there. If that one is not available, you can study the crop production by Chidda Singh. Just refer one book, that's enough. Either Rajendra Prasad or Chidda Singh. Okay, next class we will discuss about wheat technology. Thank you.
Thank you, sir. सर एक क्वेरी थी.
हाँ यार.
सर प्लीज ये जो टाइम है आप रीशेड्यूल नहीं कर सकते.
मुझे समझ में नहीं आया क्या.
सर ये जो आपने टाइम लिया मॉर्निंग वाला इसको रीशेड्यूल कर दो इवनिंग के लिए. प्लीज सर. आप खुद देख लो बच्चे नहीं आए हुए हैं अभी.
मतलब वही है, टाइम का थोड़ा सा दिक्कत है. हम मतलब देखते हैं, वही
यस
डिस्कस करके.
सर. ओके सर. थैंक यू.